So we can calculate a test statistic from the information we've gathered, okay? But we need to compare the test statistic to a critical value so we can decide whether to reject or fail to reject a null hypothesis. So this question just asks us to determine the critical value. Sample of 15 people, n equals 15. We're testing the hypothesis at 10% significance levels. That means alpha is 0.10. And another thing you need to know when you're trying to gather a test statistic is whether it's a one-tailed or two-tailed test. So a linguistics expert is interested in learning about the amount of time people in his industry spend studying a new language. Random sample, hypothesis about the mean new language per year. Nothing is said greater than or less than, or different, anything to tell us that whether it's left or right or two-tailed. Conducts a one-mean hypothesis 10%. To test the recent publication that the amount of time people in his industry are studying a new language was 30 minutes per week. None of this indicates like a one-tailed test. So I think we have to assume it's two-tailed. Let me read it one last time here. Yeah, so none of this tells us whether it's that it's a one-tailed test. So we just need to compare like this sample mean to a population mean. It would say like the researcher wants to know whether the mean time is decreased. That would be a one-tailed test, okay? Or whether the mean time is increased. That would be a one-tailed test. But since it didn't say, it's a two-tailed test. And that's significant because now we got to use the table and consider our alpha of 0.10. That if alpha is 0.10, that's the area in the tails here. That means you need to split it up evenly amongst these two tails. So we should be using alpha, so we should be using 0.05 when we look at these t values. Okay, because a table value only tells you areas to the left. Okay, a table value only tells you test statistics that represent area to the left of the value. Okay, so any value you get from the table, at least in Newton, there are two-tailed tables out there. It just tells you this area over here. Okay, so that's why we needed to find 0.05, not 0.10. So 0.05, n equals 15. That means our degrees of freedom is 15 minus 1 for a one sample test. So we're using 14 for our degrees of freedom, so 1.761 is our critical value. But I think it's positive or negative. So we should put the plus or minus sign. And I don't see it. How does Newton want us to do that? Let's copy and paste maybe.